Hi, grade 8 students. This is a mathematics video, and in this video, I'm going to solve with you worksheet 2A in our lesson square root, the worksheet I sent this week. This is the solution of the worksheet. Let me start. We should, in exercise number 1, simplify the following square roots. As I told you, we have a rule or a general form of a square root. It is radical a squared, which is equal to a. How did I get a? Since inside the radical I have a squared, it is a number squared and I want to get its root. Its root means what was the number before making it squared. So the rule says the square cancels the radical and it gets out as a. Let me start. I have radical 7 squared. Inside the radical, I have a number squared, so I have an exponent 2. The square always cancels the radical, and my root will be 7. Radical 15 squared, also since it is a number squared, the rule says the square cancels the radical. We cancel them in this way, and it comes out as 15. Radical 9 squared, on the same rule, the square cancels the radical and the root is 9. Radical 21 squared, the squared cancels the radical and the root is 21. Now I have 13 squared, radical 13 squared. It's the same, but I have written the number inside parentheses. So the squared cancels the radical and it gets out as 13. Now I have radical 4 squared. It is a number squared inside the radical. So the squared cancels the radical and the root is 4. Now I have radical 17, all of it squared. Now all the radical is inside parentheses and outside I have a square. On the same rule, I say the square, the exponent 2 cancels the radical and the root is 17. Radical 10, all of it squared. Also, the square cancels the radical and the root is 10. Now I have radical minus 8 inside the radical, all of it squared. I have talked about this in our last lesson, which is powers. Minus 8 is considered a negative base. It is a base with the minus. On the parentheses, I have exponent 2, which is even. When I have an even exponent, the negative becomes positive. So now I have 8 as if it is radical 8 squared. So the squared cancels the radical and it comes out as 8. It's never minus here, okay? Since the minus with the exponent 2 becomes positive. Radical minus 3, all of it squared. Also, since I have a negative base, the minus becomes positive and the squared cancels the radical, so it comes out as a 3. Radical minus 14 squared, this is a negative base and the exponent is even, it becomes positive, so the squared cancels the radical, it comes out as 14. Now, radical square and inside I have 5, so the square now is on the radical. Also on the same rule, the square cancels the radical and it comes out as 5. This as if it is radical 5 times radical 5, so I have written it radical 5 squared. Radical 19 squared, also the squared cancels the radical, it comes out as 19. Now I have minus radical 5 squared. The minus outside, does it have anything to do with the square inside the radical? Of course, no. So the minus outside stays as it is, minus. And now I say the square cancels the radical and it comes out as 5. So if the minus is outside the radical, it stays where it is, outside. I have nothing to do with this minus. Now I apply the rule. I have radical 23 squared, so the squared cancels the radical and my answer is 23. Minus radical minus 2, all of it squared. First, I deal with the minus outside, it stays as minus. Now inside the radical, I have a negative base. Since it is a negative base, what I do is the negative becomes positive since the exponent is even and the squared cancels the radical, so my answer is 2. The same as in this example. The minus stays outside, minus 13 all of it squared. This minus becomes positive and the squared cancels the radical. It comes out as 13. Now let's look here, please. We should specify these two examples, this example and the one I was solving before. When we have parentheses on the number and the sign, the square is considered for both. So this is considered as a negative base. Now here, the square is only for the 11. It has nothing to do with the minus. So this is a negative radicand. And as I said in my lecture, when we have a negative number inside the radical, this does not exist since the radicand is negative. The same here, radical minus 34 squared. Since minus has nothing to do with the squared, so it stays minus. So inside I will have a negative radicand. This does not exist. Radical minus 4, also I have a negative radicand and this does not exist. Please pay attention for these three examples. Now I have radical 9. Inside the parentheses, is the number written as a number squared? Of course, no. I have 9. I have no squared on the 9. So I ask another question. Can we write 9 as a perfect squared? And again, what are perfect squares? 1 is written as 1 squared. 4 is written as 2 squared. 9 is written as 3 squared. These perfect squares, please study them and memorize them well. They are very important. So 9 can be written as perfect squared. So we write it radical 3 squared. Now we apply the rule. The square cancels the radical. So my answer is 3. Radical 49. Is 49 a perfect squared? Yes, it is radical 7 squared. The square cancels the radical. So the root is here, the root is 7. Now, let me continue. Radical 81, so now my answers will come. Radical 81, 81 can be written as a perfect squared. It is 9 squared, so the squared cancels the radical, it comes out as 9. Radical 121, also it's written as perfect squared, it's 11 squared. The squared cancels the radical, it comes out as 11. Radical 36 can be written as a perfect squared. 36 is 6 squared, so it is radical 6 squared. And the squared cancels the radical, it comes out as 6. Now this is the answer of radical 7 squared. This is the answer of radical 9 squared, radical 11 squared, and radical 6 squared. Now I have radical 60. 60, is it a perfect squared? No, it's not a perfect squared. As I said, when I have a number inside the radical which has no perfect squared, I should decompose it into prime factors using prime factorization. So I write 60 and I try to divide 60 starting from 2. 60 divided by 2 is 30. 30 divided by 2 is 15. Here I should not have 4 or 6 or 9. Here I should only have prime numbers. That's why it's called prime factorization. I'm decomposing the number into prime factors. 15 divided by 3 is 5, since 15 cannot be divisible by 2 anymore. 5 divided by 5 is 1. My prime factorization finishes when the answer is 1. Now, what are the prime factors of 60? They are 2 squared, 3 one time, and 5 one time. Now, these prime factors, I replace them inside the radical instead of 60. So I write radical 2 squared times 3 times 5. Now I look inside the radical. The 2 has a squared on it, so it can come out from the radical. It comes out as 2, since I say the square cancels the radical. So I will have 2 outside. 3 has no square, so it stays inside the radical, and 5 stays inside the radical. Now inside the radical, I have 3 times 5. I write it as 2 radical 15. I have another example, which is radical 72. I also do the prime factorization. So these are the prime factors of 72. Now I replace them inside the radical of 72. Now 2 square come outside as 2. This 2 has no square on it, so it stays inside the radical. 3 square comes out as a 3. So now outside I have 2 and 3. So I should multiply them. I write 2 times 3 and I keep keep the radical 2. 2 times 3 is 6, so the answer is 6 radical 2. Of course, I still have radical 80. These are the prime factorization of radical 80, and this is radical 450. It is solved for you. Now, in exercise number 3, reduce the following radicals. I did like this before. Radical 9 can be written as perfect squared. It's written radical 3 squared. The squared cancels the radical, it's 3. Let me solve this example with you. This is a fraction inside the radical. So what is 4? Can we write it as a perfect squared? Yes, it is 2 squared. So instead of 4, I write 2 square. Instead of 25, I write 5 square. So I have radical 2 square over 5 square. Now the 2 square comes outside as 2 and the 5 square comes outside as 5. But the 2 is in the numerator and the 5 is in the denominator. This is how we do it. Radical 10,000, I do the prime factorization of 10,000. This is the prime factorization. 2 square comes out as 2. 2 square comes out as 2. So I will have 2 times 2 times 5 times 5. And the answer is 100. Radical 0.81, I write it 81 times 10 to the power negative 2 as a negative power of 10. Here I changed from a decimal number into a whole number, okay? Now, 81 can be written as a perfect squared. It's written 9 squared. Now, 9 squared comes out as 9, and 10 to the power negative 1 comes at 10 to the power negative 2 comes out as 10 to the power negative 1. Now, radical 15 squared, the square cancels the radical, it's 15. Radical 1 over radical 4. Of course, radical 1, it's written radical 1 squared, since the perfect squared of 1 is 1 squared, and radical 4 is written as radical 2 squared. Radical 1 squared comes out as 1, and radical 2 squared comes out as 2. Now I have a negative base. As I said, since the exponent is even, the negative becomes positive, and the squared cancels the radical, so my answer is 10. I have another example here for you. I solved like this a lot before, so I will give you only the solution of these questions because I solved like this a lot. Now let's move to this table here. Okay, I have the value of a number a first, it's negative 3. I should find a squared. As I said, the square of any number, if it is negative or if it's positive, I write it between parentheses. So the square of minus 3, I write negative 3, all of it squared. I cannot write negative 3 squared without parentheses. Why? Because in this way, I will be giving the square only for the 3, but the square is given for both the number and the sign. What is the answer here? Since I have a negative base, the exponent is even, so of course my answer is 9. And the others are the same. These are very easy. I solved like this before. Let me now tell you how I get radical a squared. The answer of radical a squared, I write radical and I replace minus 3 squared inside. Now this is a negative base, so it is 3, and I solved like this before. Please watch them well, check the solution. This is very important. Now I have radical a squared. Now a squared is radical 3 squared. So I write it in this way, radical 3 squared. The square cancels the radical and I will have radical 3. So these are the answers of these questions. Now, the last question, we should circle the correct answer in each case with justification. It's very important to give the justification. Radical 25, which answer of these 3? 25 can be written as a perfect squared, so I write it radical 5 squared, so the answer is 5, so I circle number 5. Radical negative 4, this is a negative radicand, and as I said, negative radicands does not exist, so this is a wrong form. It cannot be calculated. 3 is the square root of what? It's not the square root of radical 9. It is the square root of 9, since radical 9 gives me 3. Minus 3 over 2 is which one of these? It's the root of which one of these. Of course, since I have negative in the fraction, so of course this one has no negative in it, this one has no negative, this one has a negative. The square root of 9, it's radical 3 squared, so it comes out as a 3. Radical 4, of course, the negative is outside, I leave it. This is radical 2 squared, so I will give you the solution. This is the solution of this question. Now, radical 256, I do the prime factorization of 256. It's written as a perfect square, 16 square, it comes out as 16. Radical 10,000, I solve it with you. I make the prime factorization and the answer is 100. This was the solution of our worksheet. Please check your solution and correct your mistakes. And please, when you solve a solution that I send, take your time when solving the worksheet. The worksheet I'm sending, the exercises of this worksheet are the same as the exercises I'm solving in the lecture. So please watch the lecture well, solve the exercises before solving the worksheet in a wrong way. Thank you for your time, and if you have any question, please contact me.